Hi, my name is Steve Salavan. I am a site reliability engineer at a company known as Twitter. In fact, somewhat unlike our last speaker, I do Twitter, in fact. So anyways, I'm here to talk to you about how we have successfully used Ansible at Twitter. This talk is going to be predominantly about how Ansible has improved our working relationship with bare metal in particular, and how we have used it to basically simplify the management of bare metal without, basically needing to drink whiskey very frequently. And so, a little bit about myself. So, my career started out at a company called Red Hat, where I basically worked amongst the RHN satellite department. And what was interesting about that was that sitting in the cube across from me was a fellow working on a tool that some of y'all might be familiar with called Cobbler. And basically, as time progressed, I ended up getting a chance to work with him on both the Funk project as well, which was pretty neat. And as it turns out, basically, since my Red Hat days, I've gone off to a bunch of different companies, Tumblr, Google, and now I'm at Twitter working as a site reliability engineer here out of the New York office. So, sorry, I kind of used a lot of these transitions because it's the first time I use Keynote, so forgive me if you see a lot of these throughout the presentation. So the question that I'm certain is on everybody's minds: what does Twitter actually look like? When we peel away the 140 characters and the hashtags, what makes it tick, or tweet, if you will? First off, we have multiple data centers, and we have many thousands of machines running CentOS. So if any of y'all have had an experience with CentOS, you would find that you would have a very familiar environment at Twitter. Running on top of this environment are many different services and many different data stores. And so when I talk about service, I'm talking largely about a piece of code, maybe written in Scala or Java, Ruby, Python, really a vast panoply of different languages that basically implement some part of the Twitter functionality. This could be, for instance, user information. This could be something much more general than that. This could be search. Regardless, your Twitter experience is rendered by a vast number of different services, all working in tandem with one another, and working in tandem also with a large number of data stores. These could be MySQL, these could be Redis. Redis is used quite heavily, Memcache. So there's some Postgres in there. It's just a big old box of different data stores. And what's particularly interesting about our infrastructure is that a lot of this runs on top of a framework known as Apache Aurora and Apache Mesos. So anybody, it's going to be a little bit of an interactive talk. So feel free to holler at me or raise your hand. This is going to be the first point of interaction. How many of you are familiar with either Aurora or Mesos at this point? Yes, excellent. I'm so incredibly glad to see that. So Aurora and Mesos are basically, I know that y'all have heard over the past couple of hours about this thing called Docker. So you can think of the Aurora and Mesos environment as being something like Docker, except with service scheduling and service health checking built in. If you can think of a vast distributed monet, it is something like that. And many of our services run on it because using this particular tool, if one of the service shards goes down, it can get very quickly rescheduled in another box that is not having such issues. And so that is how we have staved away the fail whale, as it were. So another thing that you're going to be hearing me just hammer on like crazy throughout this talk is that we have an API for server inventory information. This includes host names, this includes facts, this includes attributes, and we call this colloquially the single point of truth. And the single point of truth is basically the one place you always go to get truth about your infrastructure, which, as you can imagine, is great both for driving automation and other things, such as Puppet, which is something that we have built into our infrastructure. Now, another show of hands, how many of y'all have had an experience with Puppet? Now, take your hand down if you have had a good experience with Puppet. Oh, yeah, so Puppet isn't terrible, right? Puppet, generally, we had a lot of precedent with Puppet. And, there are a lot of things that Puppet generally does, fairly okay, in the end. And I think one of the things you find that Puppet does not particularly do well in the end is what we would call orchestrated actions, which are basically things throughout your infrastructure that you need to do right now. So, before Ansible came around, the way that we would do this would be, we found largely that, there were a lot of things that needed to kind of happen at the same time, a lot of things that needed to happen perhaps after another step had been completed, and Puppet just wasn't really getting the job done. Puppet, is much better for the asynchronous kind of mode, whereas we needed something that just kind of did it right now. And those things included everything from service deploys, particularly database changes, such as replication changes, schema changes, migrations, everything under the sun, related to databases. Just, really Puppet really wasn't scratching that itch. Additionally, kind of closer to the bare metal kind of parts of things, basically bonding or unbonding network interfaces, talking to switches, kernel upgrades, RPM upgrades, BIOS upgrades, and my particular favorite, triggering Puppet to actually do the thing you wanted it to do, which I'm fairly certain many of us have had experiences with. So before Ansible, how did we get this done? Well, initially, we would sometimes use attributes on our single point of truth, and I'll have a whole slide about that, so you hear me ranting about that. I'll go into deeper detail in just a little bit. But, one way was that we would set an attribute on one of our hosts and then let Puppet just push the change through, which, generally, in certain cases worked all right. Most frequently, though, you would see an elaborate setup either including shell scripts, Python or Ruby scripts, Capistrano scripts, and hating your life. In general, are just ways that these things were kind of done. In general, very ad hoc, and they worked okay, but maybe not exactly the way you would have wanted them to. And so, out of a lot of this thinking came the idea of a package that we called Servermate to basically handle doing orchestrated actions. And several of our engineers attempted to unify this process basically using Python as well as Paramiko to actually reach out to the various machines. It would work in tandem with the single point of truth to do this work. And we started going down that route, and then we realized, dang, there is quite a lot of code you have to write to actually make this a real thing. And so, when we discovered that Ansible was around and doing some really great work, this was our general reaction throughout the company. So, really just, I'm just going to let this one roll out because it's really important to the talk here. Excellent. So why did we choose Ansible? Well, there are a couple of big reasons. Predominantly, Python is a very, very, very highly regarded language at Twitter. In fact, we would probably call it a first-class language because it's used by so many different kinds of people, either for driving automation, for writing services, for really doing pretty much everything under the sun. And Ansible additionally provided, a means with which you could specify tasks that would pass the 3 a.m. test, and that'll be the next set of slides. But so keep on point for that. But it provided essentially idioms that you could follow that would do what they said on the tin. And as we well know about many pieces of cloud infrastructure, there are a lot of things that don't, but Ansible does, and that is fantastic. And that is one of the things that we loved particularly about it. Additionally, a lot of the work that we were re-implementing in Servermate 1.0 was already completed in Ansible, and also had a very large open source community continuously working on it and working out any of the issues, which was fantastic. Additionally, the nature of Ansible being that you could drop in modules or plugins or, pretty much any arbitrary kind of task in Python appealed to us because that would allow us to tie in with much greater coupling Ansible alongside some of our internal tools. Additionally, once those were written, the composability of the playbook concept was also fairly appealing to us because not only was there an idiomatic means, but once you got the job done, you wouldn't have to rewrite the code. And that is that is something you find quite a lot in, I think, a big tech organization. Like, a lot of people end up duplicating effort. Ansible seems to be a tool that is designed, from the very get-go, like ideologically, to work against that. And finally, and I think this is one of the most important points, most of the site reliability engineers and database reliability engineers were familiar with Ansible. Some had actually used it in past positions they had held. Honestly, like this, this particular tool just seemed to really be kind of like simpatico to our sort of use case. And so to kind of go back to idiom and the importance of idiom and why I think idiom is so incredibly important, I'm going to basically kind of guide you through a 3 a.m. pre-Ansible, perhaps likely pre-Twitter, example that I had myself working as a site reliability engineer. So imagine, if you will, that you're asleep and you're on call, and 3 a.m. rolls around, and typically when I dream, I usually dream of this. I dream of basically being Rick Wakeman from the band Yes, and I enjoy basically like standing behind my synthesizer cage and then playing a Bach cantata, maybe a little fugue, and then as I'm going into the crescendo, I get a phone call. And on the other end of the line is a very pleasant and, congenial gent, generally a nice person, a little bit metallic. He basically says, "Major duty alert, major duty alert, 500s increased." And so, that typically, it's a little bit disquieting. It feels a little, strange to be woken up at 3 a.m. by this. And so you're like, sweet, well, I'm going to go break into my server automation. And so you do that and you're like, oh, crap. This is not going to be a good night. And so you go and reach for your burp coffee and just keep going on. And so, I think the way that you defend against having this case occur to you is by constantly working on ensuring that you are following strict idioms that you can understand with your 3 a.m. brain. And Ansible is pretty much custom made for that task. It is absolutely beautiful for it. And so, enter ServerMate 2.0. So within Twitter, we have integrated Ansible with our single point of truth. The single point of truth provides host information, Ansible groups, facts for doing things, as well as attributes, with which you can drive conditional parts of your automation. Additionally, it is integrated with a persistent database to record the success and failure states of playbooks. And this is good because in general, it allows, the idempotency that they talk a lot about, it allows multiple SREs to ensure that there will always be an idempotent run, particularly in cases where you don't necessarily have tasks that are, really great for idempotency, particularly database tasks. And so the persistent database we found has been a really crucial integration with ServerMate. Another thing that we're going to be talking about in just a little bit is that we basically take Ansible, take all of our custom modules and our custom, playbook helpers, YAML files and whatnot, and we package it all together into one single binary file called a PEX. And we do this via a tool called Pants. Now, so a show of hands out there. So how many of y'all are into Python? Python is a language. I get the feeling there's a good Python vibe going on in the audience right now. And I like that. Python is a fantastic language. Now, out of y'all who use Python, how many of you are just really into packaging, really dig Python packaging? Something you really enjoy it. That's what I thought. So Pants was developed by several of our engineers at Twitter, John C. Royce and Bill Farner, largely because I think they just hated Python packaging and wanted to find a way wherein you could encapsulate a full Python environment into a singular deployable binary. This, I think, in many ways improves sanity, both in terms of shipping services to production, as well as simplifying things like the setup of Ansible. Because using Pants, we're able to construct that. And additionally, we have a set of different plugins that are included with that. So let me tell you a little bit about sort of like these two things that I brought up. I want to drill down a little bit into greater detail because these are two things that have really helped us out at Twitter as we've grown and have increased the size of our fleet of bare metal. First and foremost, the single point of truth. So I feel like I'm asking you to bring up your hands all the time, so definitely like call me out on that if that's a little bit too much. But how many of y'all use bare metal? How many of y'all have like a bare metal kind of environment in your situation? So, wow, quite a plurality. That's immense. So, one of the things that I think, almost anybody who deals with bare metal finds is that the more bare metal you have, the harder it is to keep track of it. And in particular, the harder it is to, kind of keep track of all the systems around it that do things to the bare metal. Things like DNS, things like your RPM repos, things like your Kickstart tool, if you will. And so out of this thinking came the notion of providing a unified, singular API for storing information strictly about all of the hardware in your infrastructure. This can include, basically very basic information like how many CPUs, how much RAM is on the machine, information about your disks, and most importantly, for many cases, the way that your network interfaces and switches are controlled. Additionally, an ideal point of truth, and one that I'll be mentioning in just a moment, allows for the setting of both what we would call attributes, which could be permanent or ephemeral. Examples of these include, for instance, groups. So, for instance, let's say like you intake a new machine, you want it to become a webhead. So, you would assign an attribute to that machine and say, that is going into the webheads group. And by doing so, you would be able to communicate that information to your config management system because your config management system ideally would be coupled with the point of truth. And so, in fact, we have deep coupling between ours, between both Ansible and Puppet. Additionally, there are cases where, for instance, you'd like to, drive changes throughout your environment. These could be, for instance, attributes that network switches might, be able to query for changing the VLAN your machine is on, or perhaps a tag for saying that you should upgrade an RPM on a particular node, something that might indicate that it's a canary node for all of your various changes in your head repo for either Ansible or Puppet. Arbitrary tags are just absolutely fantastic for driving change in an incremental and safe way. And a single point of truth allows you to do that without too much guff. Additionally, with an ideal point of truth, the API should allow for very flexible querying. So you should be able to be like, tell me how many machines have 8 or 16 cores and 16 gigs of RAM. So the one that we use at Twitter is not currently open sourced, but there is one that's fantastic in the open source, and it is called Collins. It was developed by Tumblr for their own case and was integrated very tightly with many pieces of their infrastructure. I'm actually working right now on a pull request for Ansible. Hopefully in the next couple of weeks that will do that for Ansible and Collins as well, because I honestly believe that having a single point of truth working with configuration management is really the only way to keep a big unruly sort of flock, if you will, of bare metal sane and the 3 a.m. calls limited. And so, moving along, drilling down just a little bit more into Pants. So Pants is something that we have open sourced, and particularly if you use Python, it is something that I think will be exceptionally awesome for your use case. It essentially is just a build tool that is designed to compile both your code and its library dependencies and source dependencies into a single deployable binary. Now, coming from Red Hat, this for a little while felt a little bit like it was against my religion, because dynamic linking is sort of the way you do things in most of your Linux environments. However, one of the things that's kind of crazy about dynamic linking is that oftentimes you need a library version that is newer than that on the system. Sometimes you need packages that are not currently packaged as RPMs or D packages, although probably it's more of the former case and less of the latter case generally. In any case, though, Pants makes it very, very simple to take a Python project and encapsulate the full virtual env of all of its dependencies into a single executable file. And one of the things that's cool is that Python's greater than or equal to 2.7 can take one of these files, just a zip file, and execute it as if it was a Python script. And so we take that, we exploit that to its greatest potential by way of pants. And so the other great thing about PEX files is that they are portable between hosts. So let's say you're running like a Django application or something. You can take Django, you can take SQL Alchemy, you can take all the other Python libraries that you use to communicate with your backend services, compile it all together, and thereby, have very fine-grained control both over the versions of the dependent libraries you deploy with your tool, as well as not having to worry about ensuring that your environment is the same across your every host in your system. So for us, Pants generally makes it very quick and easy for both developers and users to start using Ansible. Excellent. So let's run you through kind of a case here at Twitter, where we might end up using Ansible. Database maintenance is definitely one of the areas where we've really found it to be really without peer, because again, it's phenomenal at orchestrating action in parallel or serially, and then optionally giving you control over how those things run. And so, what we'll do is that we'll basically take a playbook, we'll write a playbook and encapsulate the various steps. For instance, maybe we want to take a slave out of rotation and then do something to it, or maybe we want to push some kind of a database migration to one of the servers. And then we basically find a server group from our single point of truth and target the playbook against it. Servermate will then go out by way of Ansible and reach out to all of the hosts that it obtained from the single point of truth. And the order in which you specify, because this is really one of Ansible's strengths, it will run those in order. And then finally, the success and failure states will be persisted to the action database to ensure that you can safely rerun these, and that the steps that were already completed will not rerun and cause pain and the gnashing of the teeth. Yes?
So is Silvermane kind of your, if I could use the expression, your ENC, your external node classifier, or is it?
Well, so I think you would probably classify the single point of truth as the ENC in this particular case. The external node classifier is essentially something that takes a host's information and then provide some sort of information about the automation you should target to it. And so in this case, we're using our single point of truth to service the classification mechanism, and then just basically just using Ansible to query that, to pull down the information, and then operate on the hosts that it finds and the facts that it gets from those hosts. So that's the main reason why I really, you'll hear me hammer on it time and time again, but single points of truth are phenomenally awesome for reducing the insanity of a bare metal environment. I really could not preach more heavily about it, because they are fantastic. And so in the case of an SRE or a DRE using the Servermate tool, they'll first build it on their local machine. As you can see, there's a little pants up there just kind of doing that. And it produces a PEX file, and then you take your playbooks and you put them typically in a repo somewhere, and then you access it from within your data center. Within there, that machine will communicate with the single point of truth, will persist action states to the database, and reach out to the machines. It's very simple, it's very straightforward, and most typically, the beauty of the whole system is that a SRE can generally get going on it in about 5 or 10 minutes. The syntax of the playbook is very straightforward. The building of Ansible and all of its dependencies takes a very, very small amount of time. And if you run it on a machine that has, a fair bit of bandwidth, it should run quite well, to be honest. So, what did we have to do to make this happen? Honestly, not much. So I think our case differed from many because we had to, we were producing a binary with all of the dependencies encapsulated. And traditionally, the way that you deploy Ansible is by way of something like pip. where you bring down the Ansible code and any of its dependencies and install it into your local site packages directory of your Python distribution. So since we were building it within a single encapsulated binary, the first thing that we did was that we basically changed around a few places where there were hard-coded paths to use or share. Additionally, we changed it around to add package resources support for Ansible loaders. This is so that custom modules and tasks of ours could be bundled in with our Ansible distribution. We also superclassed the Ansible playbook class, and we did this largely because we wanted to bundle in our own inventory provider that reached out to our single point of truth. And within our code, we have, in fact, injected our own that includes the integration talking to that system. Next up, we basically created a custom host class to add some properties that you will find commonly on every host in our environment. And finally, we added a module that hooked into various parts of the execution flow of Ansible that would take various states and persist them into a SQL database via SQL Alchemy, one of the greatest Python SQL libraries there is, in my opinion. So, what's the hashtag verdict? The hashtag verdict is that Ansible does what it says on the tin. It has indeed greatly simplified change and action orchestration across the vast majority of our environment and across all of the teams that SREs are embedded with. So a little bit of tiny, little sidebar, a little background on SRE at Twitter. So it tends to be that a site reliability engineer is embedded with a team that implements a service. And oftentimes, the way that a service is deployed, the way that it runs, can be a little bit different between teams. And so with Ansible, helps to take care of a lot of the tasks that SREs were typically, writing for themselves in a way that everybody could take advantage of, and in a way that, kind of allowed for, an idiom that we could apply throughout our entire team. And so that's really one of the best things about Ansible for us. It's really helped us to reduce a vast amount of the duplication of effort that you find in that kind of a model. Additionally, Ansible works as well against thousands of machines as it does against a handful. I know in a lot of cases, in my own personal usage of Ansible, I usually use it against really just about 5 or 10 machines. But we have found it to be very effective against the thousands of machines that sometimes orchestrated change needs to occur against. One of the cases you'll find in particular that this is good for is RPM upgrades, because RPM upgrades through Puppet can sometimes be a little bit of a tempestuous affair, particularly if there are breaking changes and those changes are not backwards compatible, as is the case frequently, especially if you're like me and you're crazy and you like to backport things from Fedora. Thankfully, that doesn't happen at Twitter. That happens at other positions I have held. But regardless, RPM up. Yes, I see a question.
Yeah, when you're running Ansible against these thousands of machines, how many threads are you running it with?
So I believe we set the forks to something so we have a pretty beefy network interface, and we also have a pretty substantial box this runs on. So typically our end forks is usually 250, sometimes even 300, really depending upon the kind of task that we're executing. So, really, I think, the thing about SSH can spawn off a number of processes, and, you can keep many of them running in parallel. And so more or less we're limited, I think, strictly just by the amount of CPU capacity really at our avail. And so that's more or less why we, kind of keep our forks in that sort of a range. Additionally, one of the things that I really wanted to underline is that we've made some modifications, but the ones that we've needed to make to adapt Ansible to our use case have been minimal, with a capital M. Ansible, by far and large, its core has been good, and it has indeed, needed very few modifications. And the modifications that we have made, we will be submitting up as a pull request quite soon against y'all's GitHub. So be sure to keep an eye out for that. It's going to be chill. Looking forward to it. And so, additionally, the other thing that's cool about this is that it's really promoted unity across the SRE and DRE teams, because all of the things that we find ourselves writing will typically now write as an Ansible task or a module, add it to Servermate, suddenly, because that'll get built into a PEX that everybody uses. excuse me, everybody will soon be able to use what you just created. And as a result, there's really been a lot of uptake. A lot of teams have really hopped on board. And I think that trend will only be increasing as time progresses because it's already shown to be such a successful tool that, well, I think it's going to be a good couple of years. Also, all said. So the obligatory pimping page of various different projects. So the first one I want to talk to you about, Pants. You can find this here at pantsbuild.github.io. That includes both full documentation, Python documentation on Pants itself, and all the various things Pants can do for you. Again, since Pants is a Python DSL, a Pants build file is a Python DSL in its own right, if you like writing Python, you will find Pants to be very, it'll be very intuitive. Additionally, if you're looking for a good single point of truth, if you're having cases where all the information for your bare metal environment is just in a million different systems, it's pandemonium, I don't know, like cats and dogs raining and whatnot, Collins might be potentially up your alley. And you can find more information about Collins at tumblr.github.io/Collins. Finally, I only mentioned this very fleetingly, but should you ever, have a case where you would like resilient services to be stood up in a means that works well across an environment, I would highly recommend looking into Aurora and Mesos. In my opinion, they are transformative projects, and they have, in my own domain, if you will, they've made my life considerably easier. And so, really just, a bunch of really useful tools here that will aid both your Ansible experience as well as just your experience as a human being who likes hacking on systems. So I think that's it. That kind of went by. I was wondering if I could answer some questions.
Yeah, got a microphone right here, so please ask away. Steve's got some remarkable experience. He was at Twitter. Let's see, lots of other Tumblrs and Googles and pretty much everywhere else except the face wall, I think.
And if y'all have ever used Funk, you can ask those questions too, because I'm actually the maintainer, if you will, of the Funk project. So let's see. Looks like we got a batch.
Might have glossed over. I might have missed it, but could you talk about the reason for superclassing playbook versus using dynamic inventory like a module? Why'd you have to modify core?
That's a really good question. So a couple of reasons. First off, because we wanted to add some additional command line flags to the binary. Additionally, because we I think there was some hooking logic that we had to change just to work in with our persistent database. I mean, honestly, most of what we did in there, it's probably about 20 some odd lines of code, and most of it's just setting up the database, parsing the extra CLI args, and really not much else. I mean, ideally, I think that's probably the hackiest thing that we did. The rest of it, I think, falls very much in line. And, with the dynamic inventory thing, we wanted to be sure that the dynamic inventory provider was bundled in with the rest of our tool. And so that also was a part of changing around playbook, because what we do is that, we basically instantiate that and then pass it into the constructor of the playbook class.
Yeah, a lot of people will pass environment variables to inventory scripts as a way to get them arguments. So, obviously, if you want to do something a little bit different, you can. But for instance, if I've got an inventory script that selects part of an inventory, I want to say, give me just these users or just these cluster. You can sometimes just use set environment variables, and that can message your inventory script, and that can help too. All right, who else? Yeah.
So, given that you've built this binary bundle that includes Ansible to run on your infrastructure to fix all these problems, when are you getting rid of Puppet?
That's a really great question. Honestly, I couldn't speak to that because I think there's quite a bit of precedent, and I feel like in the end, I don't know, I just really...
Well, are there things that you or other people in your organization feel that Puppet can do that Ansible can't?
Honestly, I don't think so. I think it's just rather a matter of just kind of slowly migrating it over to Ansible, and I don't know like when that'll happen. I just kind of think in time that will eventually naturally kind of occur. I think Ansible and Puppet in many cases, the thing that's great about Ansible is that it can also do the configuration management tasks that Puppet does, and typically faster than Puppet. And so I think, in the end, it's just kind of a matter of kind of migrating the work that has been done in Puppet over to Ansible and using Ansible for new services so that the ones who are using the old means can do so.
Right.
So if I understand, with the PXE and sharing this across many groups, you also have the possibility of people stepping over each other more. Are you avoiding that in some way? Are you implementing a lock, or is this just a social convention of don't run what you're not supposed to?
So talking about stepping over one another, like in terms of like running like the same playbook at the same time. So in general, one of the things that's really great about having the state be persisted in a database is that it does provide some degree of orchestration. So like when somebody is starting a task, that is noted in the database, and so if somebody else runs the same playbook, it will check against the database and be like, somebody's working on that. Let's not do it. And so, one of the great things about a playbook in general is like when a task fails, the remaining tasks in your playbook will not continue to run. And so we've set up our hooks such that it will check to see if something is in progress, and if so, we'll break out before any action is taken.
Proper shout out here. This is Brian Coca, tremendously helpful on IRC, and I don't know how many commits you have in the system, but minor celebrity here.
Woo!
Hi. You mentioned running Ansible against some network switches and devices. That gives me a hint as to what vendor switches you're using. But in terms of, are you doing that primarily for the inventory type gathering, or are you actually pushing config changes to the switches, and if so, how often?
Well, predominantly, I don't think it's necessarily pushing config changes to the switches. I don't think we're really doing that currently with Ansible, but typically, sometimes there are cases where network interfaces are bonded at the switch, and so we have scripts that run that we can run on various machines that will call out to the various switch and cause that to not be the case. And so things like that are typically what we've wrapped Ansible automation around, because they're just very common, especially in cases when you're dealing with sort of bandwidth intensive services and the like. And so that's predominantly why we use Ansible for that case. I think in terms of pushing configuration to switches, I could totally see that, but I don't know. I feel like the NetEng team could probably weigh in on that one a little bit better.
I feel like I'm kind of doing like the Tonight Show thing or something.
You mentioned the database-backed tracking of your playbook runs and stuff. Would you consider using Tower?
That's a good question.
If you started now, because it seems like it has that and a UI.
Let me stroke my beard on that one, or probably my neck beard. I'll stroke my neck beard. Honestly, that's a good question. I really can't rule out Tower, but I think in general, for the time being, I don't know. Ultimately, if we might though. So suffice it to say, that one's up in the air, and definitely under consideration.
Tower does not currently support pants, though we may have to think about that. So.
Could we call it the Pant Tower? It's like, I got the Pant Tower running on my server. It's pretty chill. I like it. Yeah.
I was trying to wrap my mind around what you meant by running the playbooks in the database or that setup.
Good question. So, essentially, for every host, that we run a playbook against, we record essentially, we have hooks within our entire playbook setup. Main reason, I think, honestly, we subclassed, or rather, we subclassed the playbook class. It's so that each time like something occurs on a host, there will be a state persisted to the database, and that's typically like in cases where you want something only to really run once, which can oftentimes happen during, for instance, like database migrations, which has been a very compelling use case for us. By basically keeping track of that state for each one of our database hosts in a database, that has more or less kind of helped us to ensure that steps that have previously run that we wouldn't want to run again will not have that happen. So that's predominantly the reason why we use a persistent database for that sort of a thing.
Oh, you're just using it to record plays, whether plays run.
You got it. That's exactly it.
It was the way it was worded.
Oh yeah. I know the feeling. I think in general, like we are a very light user of a database. One of the things that's brilliant about Pants is the idempotency, and it's a word we've heard a lot today. But that's really like I think one of its core strengths. And in our case, we basically are just using a database to just kind of ensure that across different servers, across different teams, different SREs, and the like.
Questions back?
Yes.
Hey, so you mentioned single point of truth a bunch of times. How much work, or any, did you guys put into running that at multiple data centers, or coordinating that, keeping it consistent?
Keeping the single point of truth consistent across data centers? Good question. So typically there tends to be a point of truth for each data center. I think in most cases you'll find that to be a fairly common theme in environments where that occurs. And so, in general, I think multi-data center-based single points of truth are definitely, I know Collins definitely has a feature that supports that, but I know in our case, I believe that we keep a point of truth for only each data center. So,
Right. Anybody else? Questions? All right. Well, great. Thank you very much, Steve.
Thank you.